Sir, your voice is not audible, sir.
Okay, is it audible now?
Yes, sir.
Okay, thank you. So actually, I am explaining here uh, yesterday's first class introduction about the substitution. I think if you have any doubts in this part, you can ask me because if I don't want to, I want to solve some more problem. Okay, actually, I explained here there are three categories here. So this is the substitution for capital X and capital Y and capital Z. If you have capital X and capital Y substitutions, and there is no substitution for capital Z, then you should use the partial derivatives partial derivatives for P and Q like this. And suppose if you have the substitution for Z only, okay, then you should write the partial derivatives for P and Q like this. If you have the substitution for all the three variables, capital X, capital Y, capital Z, then you should write the partial derivatives for P and Q like this. And these two categories is transformed into type 1 or type 3, that is a function of P comma Q or function of P comma Q comma Z. And these two categories are transformed into first type or fourth type. First type, you know that. Fourth type is a separable equation. P and X are one side and Q and Y are other side. And this is the third category. This category is transformed into the first type. Okay, now, okay. Yesterday I started to solve one problem. Again, I'll repeat that problem. Problem 1. So first 50 minutes I will solve the problem. So once the time is 2:50, plus remember me. Solve P Z square into sine square X plus Q Z square cos square Y equal to 1. This is equation number 1. Here you can see that P is with Z and Q is also with Z, and P is power 1 and Q is also power 1. So you can easily identify K value, K equal to 2. And here you have sine square X and cos square Y. Okay, so if you have just X and Y, you can write the M and N value. Here X, actually here you have sine square X and cos square Y. There is no need to write M and N value here. And if K equal to 2, then capital Z equal to Z power 1 plus K from the first slide. So Z power 1 plus K, K is 2. So this is equal to Z power 3. So now to differentiate, you will get dou Z by dou small z equal to 3z square. Okay, now you should write the partial derivatives P. You have the substitution for only for z. Okay, you don't have a substitution for capital X and capital Y. So that's why you know that P equal to dou Z by dou X equal to dou Z by dou capital Z into dou capital Z divided by dou X. Okay, now this is equal to what is dou Z by dou capital Z? So we know that dou capital Z by dou Z equal to 3Z square. So just the reciprocal of this is 1 by 3Z square into dou capital Z by dou small x is capital P. Now Z square P small z square into small p equal to capital P divided by 3. Okay, similarly for Q equal to dou Z by dou Y, which is equal to dou Z by dou Z, capital Z, into dou capital Z divided by dou Y. Again, dou small z by dou capital Z is what? This is equal to 1 by 3Z square and dou capital Z by dou small y is capital Q. Okay, now if you cross multiply, you will get Z square Q equal to capital Q divided by 3. Okay, now you should substitute these two values in the given equation. Okay, one, you will get Z square P is what? P by 3. Z square Q is Q by 3. So you'll get one implies equation. One implies capital P divided by 3 into sine square x this is capital P plus capital Q divided by 3 into cos square y equal to 1. We call this is equation number 2. Okay, now this equation 2 will, you can easily see that x and p are one side and you can write q and y are other side. So this equation is a separable equation, that is a type number 4. F of x comma p equal to g of y comma q. So which is separable equation. Okay, we can write here itself, which is separable equation. Okay, now so you can rewrite equation the previous equation by capital P divided by 3 into sine square x. Please check it, the capital P by 3 sine square x. Okay, I'll write plus q by 3 into cos square y is equal to 1. Okay, now just throughout multiply by 3, you'll get capital P into sine square x plus capital Q into cos square y equal to 3. Or you can write capital P into sine square x is equal to 3 minus capital Q into cos square y equal to some constant, arbitrary constant A. So from this, I have P equal to A divided by sine square x. So 1 by sine square x is cosecant square x. Okay. Now from this second one, from these two, I have what is a Q? Q into, okay, first I'll write Q into cos square y. Q into cos square y equal to 3 plus A. Sorry, 3 minus A. So from this Q equal to 3 minus A divided by cos square y. So 3 minus A, 1 by cos square y is secant square y. So we have P and Q. Now dz equal to capital dz equal to capital Z equal d capital Z equal to capital P into dx plus capital Q into dy. Okay, now what is capital P? A cosecant square x plus Q. Q is 3 minus A into secant square y. Okay, if you integrate, you will get, if you integrate, you get capital Z equal to A into, you should write here integrating capital Z equal to A into integration of cosecant square x is minus cot x plus 3 minus A. Integration of secant square y is tan y plus some arbitrary constant b. So which is the complete solution of equation 2. Which is a complete solution of equation 2. So actually we need the complete solution of equation 1. So just replace capital Z by Z cube, small z cube. So in the next step, we'll get the final answer. So complete solution of equation 1 is Z cube, capital Z equal to Z cube, substitution, minus A into cot x plus 3 minus A into tan y plus b. So this is the final answer. So if you have any doubts, the first problem you can ask to me. Otherwise, I will go to the second problem. Okay. Solve 2 into x power 4 p square minus yz cube minus 3z square equal to 0. Okay, now you can solve this problem because here you have z, here you have z, but you don't have z here. Okay, so z is with y and q, but there is no z with x and p, so it is better to divide throughout by z square. So if you divide throughout by z square, you get 2x power 4 p square by z square plus, sorry, minus yz, okay, yq by z minus 3 equal to 0 or equal to 3. Now you can rewrite 2 into x square z power minus 1 into p whole power 2, x power 4 z power minus 2 and p square minus here y z power minus 1 q equal to 3. So yesterday I told that you should find the value of for m and the m n k only if p power and q power are 1. Now p power is 1 and q power is 1, so you can write m equal to, what is m? கொஞ்சம் பேசினா சாப்பிட்ட சரிக்கும். சொல்லுங்க. 2. M equal to 2. Okay, good. N equal to 1. K equal to
-1.
Okay, thank you. So M2 and N1 and K is -1. Okay, so now can you tell anyone what is the substitution for capital X? If M equal to 2, x power 1 minus k 1 minus m, x power 1 minus m, so x power 1 minus m is what, 2, so you'll get x power -1. Okay, x power -1. Capital X is equal to x power -1. What is capital Y?
Log.
Log. Yes.
Log
Y. Okay. Log Y and capital Z.
Log Z.
Yes. Okay. Yeah. Correct. Thank you. Log small z. Okay. Now you have the substitution for all the three variables: capital X, capital Y, capital Z. Then you should write the partial derivatives. P equal to dou z by dou x small x equal to dou z by dou capital Z into dou capital Z by dou capital X into dou capital X by dou small x. So which is equal to dou Z by dou capital Z is what? From this you can find out dou capital Z by dou small z equal to 1 by z. So now reciprocal of this is z. Dou small z by dou capital Z is reciprocal of 1 by z, that is z. Okay, into dou capital Z by dou capital X is capital P. Capital P. And from this, what is the dou x by dou small x equal to, actually capital X is equal to x power -1. So if you differentiate, you will get x power minus 2. Okay, so you get 1 by x minus 1 by x square. So minus 1 by x square or minus x power minus 2. Capital X is equal to 1 by x. If you differentiate 1 by x, you get minus 1 by x square or minus x power minus 2. Okay, so now capital X, dou capital X by dou small x is minus x power minus 2. Okay, now, okay, next slide. So P equal to, I'll just rewrite P equal to Z capital P into minus x square. Capital P into capital P into minus x square, x power minus 2. Or you can write this is P into x square divided by z power minus 1 equal to capital P, because here minus sign, so minus capital P, or z power, or okay, sorry, I think here is z only, or z power minus 1 P x square equal to minus capital P. So because this is 1 by x square, just to cross multiply, I will write here x square. Okay. Now Q equal to dou z by dou y. So dou z by dou y is, you have the substitution for all the three variables. Dou z by dou capital Z into dou capital Z by dou capital Y into dou capital Y by dou small y. Okay, now what is dou small z by dou capital Z in this case? Reciprocal of this. So reciprocal of this is Z. So Z, small z, dou Z by dou Y. Dou Z by dou Y. Okay, so dou capital Y by dou small y equal to what? 1 by small y. So this is a capital Q. This is 1 by y. Now y q by z or z power minus 1 equal to capital Q. So now what is the equation you have? So instead of x square z power minus 1 p, you can replace by minus p. Instead of this, you can replace by q. So equation 1, this is equation 1. Okay, this is equation 1. 1 implies we have 2 into minus p whole square and then q minus q equal to 3. So 2p square minus q equal to 3. This is equation number 2. So which is of the form f of p comma q equal to 0. F of p comma q equal to 0. So complete solution of equation 2. First we will find the complete solution of equation 2. What is the complete solution of equation 2? Capital Z equal to A into capital X plus B into capital Y plus C, where 2A square minus B equal to 3. Because you have 2P square minus Q equal to 3. P equal to A and Q equal to B. So 2A square minus B equal to 3. Okay, now complete solution of, instead of substitution, what is the substitution we gave? Therefore, complete solution of equation 2 is capital Z equal to, what is the substitution for capital Z? Log Z equal to A into capital X is equal to x power minus 1 plus small x power minus 1, B into capital Y equal to, what is capital Y? Log small y, yeah. But what is B from this? From this, B equal to 2A square minus 3. So you should replace this B by 2A square minus 3 into capital Y is log Y, log small y plus C. Okay. Now, actually, this is the complete solution of 1. Okay. This is the complete solution of 1. If you write complete solution of 2, first I will write the complete solution of 2 and then I will write the complete solution of 1. Okay. So capital Z equal to A into capital X plus B. This is B into capital Y plus C. Now complete solution of equation 1. So instead of capital Z, you should replace by log Z equal to A capital X is equal to x power minus 1 plus 2A square minus 3 into capital Y equal to log Y plus C. So this is the complete solution of equation 1. Okay, now third problem, solve P square plus Q square equal to Z square into X square plus Y square. Okay, now I am going to, actually I told that Z is along with P and Q, and Z is not along with X and Y. So in this case, you have Z is along with X and Y. So now it is better to divide by throughout by Z square. So if you divide by Z square, then you will get P square by Z square. So actually this is small z plus Q square by Z square equal to X square plus Y square. Or you should write this is Z power minus 2 P square plus Z power minus 2 Q square equal to X square plus Y square, or Z power minus 1 into P whole square plus Z power minus 1 into Q whole square is equal to x square plus y square. Okay, now for this problem, what is k?
-1.
K equal to -1. Okay, now, uh, okay, k is -1. K is -1. What is the substitution you will choose for z?
Log Z.
Log z. Okay, log z. So then, okay, now, sorry, I think yes. Okay, if you give a substitution, this equation reduces to which type out of 4 types? Can you predict? If you predict, then you are in the right path. You understand? I think
Type
almost.
4, sir.
Yes, very good. Type 4. Yes, because x square and y square are separated. X and y are separated. So from this you'll get p and q. So x and p and y and q. Yes. Okay. So capital Z equal to log Z. Now, okay. Only you have substitution for capital Z. Next, you should write a partial derivatives. Before partial derivative, find dou capital Z by dou small z equal to 1 by z. Okay. Now, okay. Now small p equal to dou z by dou x. So this is equal to dou z by dou small z by dou capital Z into dou capital Z by dou small x. Dou cap, what is this? This is equal to reciprocal of 1 by z. So z into this is capital P. So now p divided by small p divided by small z, or z power -1 is equal to capital P. So next, similarly for q, dou z by dou y equal to dou z by dou capital Z into dou capital Z by dou small y is equal to this is again Z. This is capital Q. So Q into Z power -1 equal to Q. So what is the previous page? So you call this is equation 1. This is capital P. So this is capital Q. So P square plus Q square equal to x square plus y square. So equation 1 implies we have capital P square plus capital Q square equal to x square plus y square. So from this you can write capital P square minus x square equal to y square minus capital Q square equal to sum a square. Because everywhere you have square, that's why I will take a square. So from these two, what is p square? P square equal to x square plus a square. So p equal to root of a square plus x square, and y square minus q square equal to a square. From this, q square equal to y square minus a square. So q equal to root of y square minus a square. So now dz equal to capital P dx plus capital Q dy. Capital P equal to root of a square plus x square into dx plus capital Q equal to root of y square minus a square into dy. If you integrate, you will get So integrating, you get capital Z equal to, so you should know the formula for root of x square plus a square equal to x by 2 into root of x square plus a square plus a square by 2 into sine h inverse of x by a plus, if you integrate root of y square minus a square, you will get y by 2 root of y square minus a square and then minus a square by 2 into cos h inverse of y by a plus some arbitrary constant b, which is a complete solution of equation 2. Which is complete solution of equation 2. So now I need the complete solution of equation 1. So capital Z equal to log Z. So just replace complete solution of equation 1. So capital Z equal to log small z, remaining everything is same, x by 2 into root of x square plus a square plus a square by 2 into sine h inverse of x by a plus y by 2 into root of a square minus a square minus a square by 2 into cos h inverse of y by a plus b. Okay, so fourth problem. Solve x plus pz whole square plus y plus 2z whole square equal to 1. So here, what is k? So actually z is with p and z is with q. Here k is z power, so z power 1, so k equal to 1. So, but here x and y is not along with p and q. So in this case, you don't write m and n value. So you should write the value of m and n if x is along with p and similarly y is along with q. So here only k value we have 1. So this implies if k is 1, capital Z equal to Z power 1 plus k. So which is equal to Z power 1 plus k. 1 plus k is 1. Z square. Now, rho capital Z by rho small z equal to 2z. Z square means 2z. So now, partial derivatives p equal to, we call this is equation 1. So p equal to rho small z by rho x, which is equal to rho small z by rho capital Z, because here is rho capital Z by rho small x. So what is this? This is the reciprocal of 2z, that is 1 by 2 small z. This is capital P. So cross multiply, we'll get z into small p equal to capital P divided by 2. Similarly, Q equal to small q equal to dou small z by dou small z by dou y, dou small z by dou y, but we have capital Z substitution. So dou z by small z by dou capital Z into dou capital Z by dou small y, and this is equal to 1 by 2 Z. Please check it. 1 by 2 small z, and dou capital Z by dou small y is capital Q. So from this we have small z into small q equal to q divided by 2. Okay. So now x plus zp. So x plus capital P by 2 whole square. Equation 1 implies x plus capital P by 2 whole square plus similarly y plus qz small y plus qz is capital Q by 2 whole square is equal to the right hand side is 1. You call this is equation 2, and you can easily identify this is comes under type number 4 separable equation. P and x are one side, another q and y are another side. So x plus capital P by 2 whole square equal to 1 minus y plus q by 2 whole square equal to, I will take this is equal to some constant a square, because you have square, that's why I'll take a square. So from this we have, if we equate the first and last, so x plus capital P by 2 whole square equal to a square means x plus P by 2 equal to a. So this implies capital P equal to capital P by 2 equal to a minus x. So capital P equal to 2 into a minus x. Similarly, from this y plus capital Q by 2 whole square equal to 1 minus a square. So from this you have y plus capital Q by 2 equal to root of 1 minus a square. I need capital Q. So capital Q by 2 equal to root of 1 minus a square minus y. So capital Q, next slide. Capital Q equal to 2 times root of 1 minus a square minus y. So we find the value of capital P and capital Q. Now the capital Z is equal to capital P dx plus capital Q into dy. So what is P? 2 into a minus x into dx. Please check it. Q is 2 into root of 1 minus a square minus y dy. If you integrate, so integrating, we will get capital Z equal to 2 into ax minus x square by 2 plus 2 into root of 1 minus a square is constant integration of dy is y minus, take 2 commonly, minus y square by 2 plus some arbitrary constant b, which is a complete solution of equation 2. Of equation 2. Now I need a complete solution of equation 1. So the only substitution is capital Z. Capital Z equal to, you can check it. Please tell what is the substitution for capital Z.
Z square.
Yeah, Z square. Complete solution of equation 1 is small z square equal to, remaining everything is same. So 2 into ax minus x square by 2 plus 2 into root of 1 minus a square into y minus v square by 2 plus b. And fifth problem. Okay, so this is a little bit different one, so that's why I choose this problem. Solve x square divided by p plus y square divided by q equal to small z. Okay, so can you tell here which value we can take? M, n, what is m and n? Okay, I'll write here. So don't write p power minus 1, because I always have p power is 1 and q power is 1. So it is better to write 1 by p into x power minus 2 plus 1 by q into y power minus 2 equal to z. So now, what is m? M is minus 2, because it is along with p. P is power 1, so m is minus 2. N is minus 2. And hence capital X is equal to x power 1 minus m. This is equal to x power 1 minus of minus 2. So 1 plus 2, that is equal to x power 3. Similarly, capital Y equal to small y power 1 minus n. So this is equal to y power 1 minus of minus 2. So y power 3. So that dou capital X divided by dou small x equal to 3x square. Similarly, dou capital Y divided by dou small y equal to 3y square. Okay, now I need partial derivatives. So small p equal to dou small z by dou small x, which is equal to, we have the substitution for capital X and capital Y. Here z is separated with the p and q. So there is no substitution for k, because z is here is not along with p and q. So that's why there is no substitution for capital Z. And you can easily identify this after the substitution, this equation reduces to which type? Dou z by dou capital X into dou capital X by dou small x. So this is equal to, this is actually what? This is P, capital P. This is 3x square. Now P, small p divided by x square equal to 3 into capital P. So this implies small p into x power minus 2 equal to 3p. So 1 by p into x power minus 2 equal to 1 by 3p. So we call this is equation number 1. So we got this is equal to 1 by 3p. Similarly for q. So q equal to dou small z by dou small y, which is equal to dou small z by dou capital Y into dou capital Y by dou small y. So this is capital Q, dou capital Y divided by dou small y, 3y square. So Q divided by y square equal to 3q. This implies q into y power minus 2 equal to 3q, or 1 by q into y power minus 2 equal to 1 by 3q. So now I am going to substitute these two values in equation 1. So this is nothing but 1 by 3p. 1 implies 1 by 3 into capital P and 1 by 3 into capital Q. The right hand side is what? Zeta. Right hand side is small z. So now this is the form function of z comma p comma q. So 1 by capital P plus 1 by capital Q equal to 3 into z. We call this is equation 2. This is of the form capital F of capital P comma capital Q and small z equal to 0. Now, so the solution of type 4 is you should start from let z equal to function of u, where u equal to capital X plus a into capital Y. Then capital P equal to dz by d small z by du, and capital Q equal to a into dz by d. So now equation 2 implies, what is equation 2? 1 by capital P plus 1 by capital Q equal to 3 into Z. Now take LCM PQ, otherwise multiply throughout by PQ. Then we'll get capital P plus capital Q equal to 3 P Q into Z. So now what is P? D small z by D. Q is A into D z by D. So 3, you should multiply P and Q. If you multiply P and Q, you will get A D z by du whole square into small z. So take D z by du commonly, you will get 1 plus A equal to 3A dz by du whole square into z. So take from these two, and taking commonly dz by du. If you take commonly dz by du, remaining you have 3a into dz by du minus, sorry, z is, I missed one z. Okay, I'll write here, minus 1 minus a is equal to 0. So dz by du is not equal to 0. If this is 0, z is constant. So this is not equal to 0, and hence this is equal to 0. Next, so since dz by du is not equal to 0, so from this we have 3az into dz by du equal to a plus 1. Now variables separable method. So 3a z dz equal to du into a plus 1. So if you integrate, you'll get 3a z square by 2 equal to, if you integrate du, you'll get u into a plus 1 plus b. So 3 by 2 a z square equal to a plus 1, but u is what? U is capital X plus a capital Y plus small b, which is a complete solution of equation 2. Which is a complete solution of equation 2. So I need a complete solution of equation 1. So only thing you should replace by capital X and capital Y by the substitution. Okay, please check it what the substitution we gave. So therefore complete solution of equation 1. One is 3 by 2 a z square equal to a plus 1. What is capital X? Capital X is equal to x cube capital X is equal to x cube plus a into capital Y. Capital Y is small y cube plus b. So this is the final answer. Okay. If you have any doubts today's problem, you can ask to me. And just I'm going to ask you the substitution only for these problems. Please wait 5 minutes. So q square y square equal to z into z minus px. So I am going to just give the hint for 2-3 problems, and then you try to solve those problems. So you can write this is q square y square equal to z square minus zpx, or zpx plus q square y square equal to z square. Now you can see that p and x and z along with p, and y is along with q. Okay. Now here you have z square, so you can keep as it is. So suppose if you write m value is because p is 1 here, so m value is 1 because x power 1, and n value is 2, not 2. You should write this is z px plus qy whole square equal to z square. So n value is also 1. Then this reduces to type number 3, that is a function of z comma p comma q. Function of capital P comma q comma z. Suppose if you divide by z square, then you'll get px by z, small z, plus qy by small z whole square equal to 1. You can rewrite small p into z power minus 1 into x plus q into z power minus 1 into y equal to 1. Now you can write m value is 1 and n value is 1 because x power 1, y power 1. So m equal to 1 and n equal to 1 and k equal to minus 1. So in this case, capital X is equal to log x, capital Y equal to log y, capital Z equal to log Z, small z. So if you use this, you will get this equation is reduces to this equation 1 is reduces to function of p comma q equal to 0. Suppose if you keep z square right hand side, if you don't divide by z square, you will get m equal to 1 and n equal to 1. So in this case, capital X is equal to log x, capital Y equal to log y. For z, there is no substitution. So that's why this equation is reduces to function of p comma q comma z equal to 0. So try to solve this problem. So tomorrow first hour I will give I will take 10 more minutes to for this type, and then I will go to Lagrange's linear equations. Thank you. If you have any doubts, you can ask me. Otherwise, you can leave. Thank you.